Good morning, one and all. I am Ms. Davishri Bhatkar from Artificial Intelligence and Machine Learning branch. I am pleased and very privileged to provide you with the briefing of our today's guest, Dr. Raju Halder, a distinguished scholar and a researcher with a remarkable background in the field of computer science and technology. Sir has completed his PhD from C.A. Foscari University of Venice, Italy in January 2009 to December 2011 and also had done M.Tech from University of Calcutta in July 2005 till July 2007. Sir is a researcher of HasLab University of Minho in Portugal from January 2016 to December 2016 and is a postdoctoral researcher of Macquarie University, Australia. Also, a postdoctoral researcher of Ca' Foscari University of Venice, Italy from July 2012 to January 2012 to July 2012. Associate System Engineer of IBM Indian Private Limited India from December 2007 to August 2008. Not only this, but Sir has been rewarded with IBM iX Certified Best Paper Award in CISIM 2011, ACSS in 2015, IRIA in 2021, and ACSS in 2020. Received research fellowship from INESC Tech Portugal. Also received research fellowship from Ministry of Education, Universities and Research, Italy. Received grant and visiting professor 2023 at National Polytechnic Institute of Toulouse in France. Sir has been sponsored in the projects and involved in various sponsored projects including research on information leakage, analysis of database query, language development of a lizard-like robotic spy surveillance system, and a health chain project which focuses on blockchain-based decentralized frameworks with IA-based predictive capabilities from tracking the long-term impact of health pandemics. Sir have played a key role in mentoring and guiding several research scholars in areas such as blockchain, machine learning, robotics, and more. He has taught a wide range of courses related to computer science and technology, including blockchain technology, programming language, formal methods, and algorithms. Sir have been actively involved in conducting a short-term course too on topics like databases, robot operating systems, and blockchain technology, both nationally and internationally. He is a member of a professional bodies like IEEE and ACM and has chaired sessions at conferences. Sir has also served as a program committee member and reviewer from various journals and conferences contributing to the academic community. We anticipate that Sir will bring valuable insights and knowledge to our event today, and his expertise in computer science and technology will be of great interest to our audience. Not only this, we have 57 registrations from various parts of Maharashtra and other like Kerala, Rajasthan, and Karnataka. I now hand over this session to Sir.
Thank you, Professor. Thank you for this introduction, nice introduction. So let me share my screen first. Yeah. Thank you. Okay, so I think...
Madam, कहते म्हणतायत
Okay, there might be some issue. Let me check.
स्क्रीनशॉट घेत आहेत काय मोबाईलचे स्क्रीनशॉट घेत आहेत काही दिसत नाही ना सरांची विंडो ब्लँक आहे
Sorry.
एकदा रिमाइंडर सर पण काही घेत नाही बोलत नाही ते काही सांगून द्या ना प्लीज जॉईन विथ युअर नेम पार्टिसिपेंट्स असं टाकून. आमचं नको 7ची 4
Is it visible to all of you?
देत नाहीये ना तो पेमेंट ऑप्शन नाही देत.
Hello?
Yes, sir, your voice is audible.
Yeah, and the screen is also visible, right?
Your desktop is there, sir.
Can you see that slide?
No, sir, it's Gmail account.
Okay. So I think some network issue. Okay, let me check.
ईमेल आय डी विजिबल आहे त्यांचं. सगळं दिसतंय तिथे आपल्याला काय ईमेल आले त्यांना. निघा नको ती होईल.
I'm facing some issue in sharing, so just.
मॅडम काय ते म्हणताय मी मेलला रिप्लाय पण केला. ओके बोला ना ते मी केला नाही. ते दिसत आहे त्याच्या पीपीटी नाही दिसत आहे. मॅडम त्यांनी हँड रेस केला नाही ना. थोड्यापूर्वी झालं ना त्यांचं त्यांच्यात हे दिसत होतं थोड्यापूर्वी स्क्रीन दिसत होता. त्यांचा व्हिडिओ गेला होता. PDF झाले. योगा. कॉल करू का सर any issue? हां.
Okay. I think now it's fine. Sorry for the.
Yes, sir.
Okay. Okay. So good morning, everyone. Let me start with some basic thing. Maybe some kind of security issues, security concerns in Bitcoin, and then we move to Ethereum decentralized application scenarios. Many of the content I have taken from this book. It's a very good book. So I like to acknowledge this thing at the beginning. Okay, so you already know because a lot of sessions you have already attended, and most of the things are already covered. So you already know that how Bitcoin or how Ethereum works. So in case of Bitcoin, what happens that if I have some some machine, some computer, and I can connect with internet. I can join this network, Bitcoin network, and I will have some kind of wallet software through which I can create some kind of transaction, right? So those transaction is something saying that I want to send some Bitcoin from my account to others account. And in this case, the transactions is being constructed and that will be broadcasted in the network. This is called flooding. You already know, so I assume that you already know the basics. So that's why I'm skipping very fast. Now, so when I talk about one transaction, that transactions will have two kinds of things. So if I look at this transaction, I think my cursor is visible. So if I look at this transaction, you can find this every transaction. This is transaction A, transaction B. Whatever transactions I have, you can find there are two kinds of things. One is that input and there will be the output. It's like a check. So whenever I issue the check, there will be the input section and there will be the output section. In case of check, the input section contains my signature, the amount, my signature, especially my signature and my account information, right? So two things: my account information, it means that from where I am taking this money, and my signature that I am authorized to do so. And one will be the output, where I have to mention to whom I am sending the money and how much money I am sending. Similarly, in Bitcoin transactions also, you have the input section where you have to mention that from where you got this money and you have to provide your signature. In the output section, you will have the information that to whom you are sending the money and how much money you are sending. So this way the transaction will be formed. So this is a kind, some kind of structure of a Bitcoin transaction where it says that this is the input section and this is the output section. In the input section, this hash talks about the previous transaction from where we are getting money, and this is the signature. And in the output section, I am mentioning to whom I have to send money. So this is the address to whom I am sending money. So this is the address I am sending, recipient address where I am sending money, and how much Bitcoin I am sending. So this is mentioned here. So this way the Bitcoin transaction will be constructed. And so these are the previous, from where we get this money that will be directed to hash pointers. Now, you already know that once I broadcast this transaction in the network, then everyone in the network can check the validity of my transaction. So for example, suppose I want to send money to Carol. So in this case, I will construct this. So this is my transaction that I have constructed where I am trying to send money. So this is me. I am trying to send money to Carol. So in this case, I have to mention here in the output section that the Carol's address and how much money I am going to send to Carol. This is the output section. And in the input section, I have to mention that from where I got money. So this is the existing transaction in the blockchain where I have already some money. So this is the reference saying that from where I am getting this money. And here I have to provide my digital signature. So this way, so what would happen in the blockchain whenever I broadcast this transaction? If I broadcast this transaction, so everyone can check the validity of this transaction, that whether this transaction is correct or not correct. What they have to do? They have to extract my signature from where I am getting money. So it means that this one, and then how much money I have and how much money I am sending to Carol. So this information to be extracted by them, and anyone in the network can check the validity because this is already there in the blockchain. So the transactions already created and it's already there in the blockchain. And this is the new transaction that I have created. So in this case, this information about one and the information about two, those will be extracted, those will be kept in this sequence, and some kind of stack based execution will happen. And I'm not explaining all the details, but it's just high level idea that you see that having this transaction inside the blockchain, and this is the transaction that I have created newly. So anyone in the network can check that whether this new transaction is correct or not correct. In that case, what you have to do, you are the participant in the network, any one of you can extract the information denoted as 2, can extract the information denoted as 1 because it is visible to everyone. So everyone can extract this 2 information, and those 2 information can be executed based on stack. So stack based execution will happen. You see, we will scan through this one, and the corresponding things will be pushed into stack and popped out of the stack. And finally, if this kind of execution happens, finally it is observed that everything is fine. So therefore, this transaction, newly created transaction, is valid. There is no issue. So this way, the validity of the transactions will happen. Now, so first I will open the, my laptop, I'll connect with internet, through my wallet software, I'll create the transaction, and then the transaction will be broadcasted in the network. So anyone in the network can check that whether this newly broadcasted transaction is valid or not valid. So now my questions to the audience, can you tell me that when double spending attack will happen? Any one of you? May I request some information? I mean, please consider it as interactive, informal interactions with you. So if any one of you know that when double spending attack happens, I mean, what is double spending attack? If you can, I cannot see the chat here. So if you can turn on your audio and you can say this. So double spending attack is nothing but, suppose I have some money in some transaction. So for example, XYZ has sent some money to me through a transaction. So I have some money mentioned in the transaction. So what I can do, I can create two different transactions where in the input section, this is the money Alice has sent to Bob. So here I have the money. In the output section, it is mentioned that how much money given to Bob and the address of the Bob. So Bob has this money, right? Now what Bob can do, Bob can create two transactions. Two transactions. And what Bob can do in the output section, Bob can send this transaction to Carol and Bob can send this money to Jane. So Bob is sending some money to Carol as well as to Jane. But which money? So if you look at the input section, the money refers to the same money obtained through this transaction. So it's nothing but this money which Alice has sent to Bob, that money is being sent this and this multiple times, double. So this is double spending attack. It is not possible to spend the same money two times. You cannot send the same money to Carol as well as Jane. So this is double spending attack if this kind of situation happens, right? So those kind of things can be overcome in the Bitcoin setting that already you know. Now, what the task of miner? Miner will accumulate all those transactions, will create block, and this is the block format that you already know. So I am not going through all these things. And then some kind of puzzle solving will happen, that is called proof of work. And in the proof of work, what happens that that you can see that this is the existing blockchain that I already have, and I am acting as the miner. So what I do, I'll create a new block considering all these new transactions in the form of Merkle tree that already you know. I am assuming that already you know. And then what I do, I will keep changing this nonce value. If I keep changing this nonce value, you see, and I compute the hash of this complete block, if I find finally the hash having required number of zeros at the beginning, I mean the hash is valid as per my restriction that I want some kind of hash of this block having a required number of zeros at the beginning. If I get such kind of hash value, then I am successful in generating this valid block. And then what I do, I will add this block on top of this existing blockchain, and then once I get this valid block, then I will add it to my blockchain copy, and then or what I do, I will broadcast it in the network so that all other participants in the network will also accept my block, will add this block to their blockchain copies also. That is the in general how blockchain works, right? Working principle of Bitcoin. Not blockchain works, this is very specific to Bitcoin. In general, blockchain might use different algorithms for different components. So this is the steps that Bitcoin follows. So anyone anytime can join the network, can listen the transactions whatever broadcasted in the network, can validate some kind of some transactions if they wish, or even all transactions if they wish. And then what miner will do, miner will assemble new block considering some of the transactions he or she is receiving, and then he or she will go through the proof of work by changing the nonce values, by computing hash again and again for the block. If valid hash is being obtained, then that valid block will be broadcast in the network, and other participants, when they receive this valid block, they will check that whether this proposed block is valid or not, and then accordingly they will also accept it, they will add it to their blockchain copy. So that's the way new block will be added to all blockchains. But in this process, of course, some kind of incentive will be given to the miners, which is called rewards and some kind of transaction fees, and through which, I mean, this is a profit for the miner. So to motivate them to work honestly. That is the thing. And you can see this profit is nothing but this would be added in the form of Coinbase transaction at the beginning. So this is the reward given to the miner who is creating this block. And these are the transactions for the other participants in the network. Now, Bitcoin can suffer from different kinds of attacks. So let me highlight few of the attacks that security threats that can have in Bitcoin blockchain. So what I already mentioned, that double spending attack, right? If this is the situation currently, this is my existing blockchain, and suddenly I find that two new blocks are proposed by two different miners or even same miners, I don't know, but by the network participants, two blocks or network miners, two blocks are proposed at the same time, almost at the same time. And when I check that this block contains this transaction where Alice is sending some money to Bob. So in the output section, Alice has mentioned that I want to send maybe 5 Bitcoin to Bob. But how Alice is getting that 5 Bitcoin, that is being mentioned in the input section of the transaction. In the output section, it is mentioned that Alice is sending this Bitcoin to Bob, and this 5 Bitcoin. But this 5 Bitcoin, from where Alice has obtained, it is mentioned in the input section, and that is nothing but it is obtained from this previous transaction. Similarly, it is also observed that in other block, whatever proposed at the same time almost, there is also another transaction where it is mentioned that Alice is sending some money to her friend. So you see, here also in the output section, it is mentioned that send money to the friend. And how much money? Maybe 5 Bitcoin. From where the 5 Bitcoin is obtained, that is also, referring the same input, same transaction inside the blockchain. It means that this is double spending attack. Same money, this is the money, it is being used one time, second time. So this is double spending attack because they are referring to the same input amount from the previous transaction. So therefore, okay, just a minute. Oh, but stamp paper, 100 का stamp paper चाहिए.
स्टाम्प ही है सर, ये ऑनलाइन निकला हुआ है, ऑनलाइन हुआ.
Yeah, just a minute. Okay, sorry, I got. Okay, so what's happening here that I mentioned that this is double spending attack. So in this settings, what we have to do. Um, so how to prevent this double spending attack? In this case, what will happen if the current situation is this? If the current situation is double spending attack, then we have to wait. So there is some kind of multiple branches happened. So we have to wait. Okay. So in this situation, if such kind of double spending attack will be the situation, in this case, if I have this kind of situation that multiple branches have been created, in this case, I have to just wait. And if I wait for some time, then I will find that some other miners, new miners, they are also going to propose something new. And in this case, a new block will be created by them or will be proposed by them. If I find the new block is being constructed on top of it, then what is happening? This branch is going to be okay. No, it's not working, this eraser. So if it's not, I mean, if we wait for some time, we find that some new blocks are going to be proposed. And when this will be proposed on top of it, I find this branch is going to be the longest branch. And in that case, and this branch going to be the shortest one. So this block will be just, ignored by the network. It will be considered as the orphaned block. So if this is ignored, then the double spending attack is somehow, overcome. So in this case, only this green color transaction will be considered as the valid transactions, and all these double spending things will be just ignored by the network. This way double spending attack can be prevented. And in this case, of course, if I do something bad, then if I do something bad like double spending attack, of course network cannot do any punishment, right? Cannot punish me because there is no centralized authority. In this case, what the policy is that the protocol says that, okay, if some miners working honestly, they can be awarded. So in this case, if some miners trying to avoid this kind of double spending attack, they will be rewarded. So that's the positive thing to convince to motivate motivate the miners to honestly to work in the network honestly. Okay, so that I already mentioned. So here, what I want to highlight here, that suppose what is the default strategy that miners should always follow. Number one, if I want to create a block, I should consider all the transactions that I have received now, and then I have to include them in the block. I should not ignore any of the transactions in the network. It means that if I receive, for example, 10 transactions, I should consider all those 10 transactions inside the block. I should not discard any of the transactions that I have already received. Second, if I find multiple blocks coming from different miners, so if existing blockchain can have multiple chains, right? So which chain is the longest one? I have to consider only that chain to mine on top of that. So as a miner, I should propose a new block on top of longest chain. Also, all the other network nodes should accept that block and to add them on the longest chain. Third strategy is that whenever I find two blocks at the same time, and if I find that there is some transactions overlapping in both of the blocks, I should consider the first one and I should ignore the second one. First block should always be hard. And as a miner, whenever I am able to create a new block, immediately I should announce it. So I should not hide it that I have got some kind of valid block as a miner and I am hiding, I will announce it later. No, I should announce it at the beginning, immediately. So these are the default strategy that miner should follow. But there might be a situation that even though these default strategies are there, as a miner I can deviate from that default strategy. It's up to me. I am not controlled under anyone, right? No one is controlling me. So what I can do, I can deviate little bit. I have some computer power, right? I have some computer devices and that has some kind of computation power. So if I have some computation power, it could not be very high, but it is some fraction of the global computation power what the network has. In the network, lot of devices are working, doing mining process. So lot of computation power is there in the network overall in global level. But locally, I have some computer which is some fraction of computation power compared to the global computation power. So having this fraction of computation power, if I deviate this default strategy, can I be winner? In some cases, can I do some kind of attack? Let's see. Suppose this is the existing blockchain I have, where I observed that some person has sent some Bitcoin to another person. So M has sent some Bitcoin to Bob. In this situation, what I can do, if I have lot of computation power, then I can start doing mining process. And since I am the attacker, what I do, I try to make a double spending attack because I am M. And I have lot of computation power. What I do, I will create another block where I will generate a new transaction sending the same money to my friend. So this is a double spending attack, right? So the money is being sent to Bob. At the same time, same money is being sent to my friend. So this is a double spending attack. What I can do, I can consider this double spending transaction inside another block, and I can act as a miner, and I can mine lot of blocks at the same time because I have lot of computation power. If I can generate lot of valid blocks at the same time, then I can immediately announce them in the network. So when you will receive all these blocks at the same time, and if you add them here, you can find that this is the chain longest. So now you can find that this becomes the longest chain, right? This becomes the longest chain. So when this becomes the longest chain, this becomes the valid chain, valid blockchain, and this will be just ignored. So you can find also, even though I have sent some money to Bob, and that's why Bob has given me some kind of services or maybe product. But later, what I can do, I can send the same money to my friend, and I can make this one valid, and I can ignore it from the network. So eventually, Bob will not get that money finally. So this is the loss of Bob. I mean, as aim, I got this product, I got this service, but I have not paid anything because the payment I made it to my friends. So that kind of attack is possible. So this is called forking attack. Of course, it is possible, this kind of attack, when I have more than 50% of computation power. Okay, so in this case, but of course, practically, see, over this last 10-12 years, it is not observed. Even though this kind of attack is possible having more than 50% of computation power in the network, but practically it's quite, it is not observed yet because it's completely decentralized. There is no such group, no such mining pool having just more than 50% of hash power. That's why this kind of attack is not even, has not been observed yet. So now, what is the next? That, of course, this is an open problem. Here you can find that so if this kind of questions I ask, that suppose in the Bitcoin, in the blockchain, I have some amount. Is it possible to steal that money by someone else? Is it possible? For example, there are some addresses of mine and I have all the money available in those addresses. So is it possible that anyone else, the attacker, will steal my money? Of course, no. Why no? Because to get that money, to redeem that money, they require digital signature. But since I know my private key only, I can only provide my digital signature. So without my digital signature, that money cannot be redeemed. So anyone else cannot steal money. Second, if I issue some transaction, if I broadcast some transaction, is it possible that that transaction will be suppressed by the network? Yes, for some time. For some time. Maybe some of the miners, they are enemy of mine and they will not consider my transaction. It may happen for some of the time. But if the transaction will be in the network for a longer period of time, its priority will increase, and eventually in the world there must be some miner who are quite honest and who doesn't know me and he is not enemy of mine, so he or she will consider my transaction. So therefore I can say that yes, the transaction can be suppressed from the for some time, but it will not happen forever. Can we change the blockchain reward? No, it's hard coded part of the protocol. No one can change it. Destroy confidence in Bitcoin? Yes. If this kind of attack happens in the network, eventually the confidence in the Bitcoin will decrease and that can be destroyed by the attackers. But this kind of 51% attacks, even though possible theoretically, practically it is not observed yet. Let me tell you another kind of attack. For example, this is a kind of blockchain that I have. And then suppose as a miner, I have some computation power. What I can do, I can start doing the mining process. And suppose I am successful in getting 2 blocks at the same time. What I do not announce it in the network. I will keep it secret. So now what will happen? This will be the current state of the blockchain, and other miners also trying to mine the blocks. Suppose other miners are working here. So suppose a new miner has introduced a new block, and that is on top of the existing blockchain. That's fine. As attacker, what I do, I immediately, since I have already got 2 valid blocks, I immediately will announce these 2 blocks at the same time. If I announce these 2 blocks at the same time, then if you look at, you can find this will become the longest chain and this will become the shortest chain. So in this case, this block will be ignored by the network, even though it is being introduced by honest miner. So it means that by hiding something, even though I got some valid blocks, but I have kept it hidden. And when I find that other miners introduced some new blocks, immediately I announce it so that my chain becomes the longest chain and his chain will become the shorter one. So his block will be ignored. It means that even though the honest miner is doing some work in the network, investing their effort, but somehow I am nullifying their honest effort. So this is a kind of attack is also possible, which is called block withholding attack. But there might be some situations like this. Suppose I got, as miner attack, malicious miner, I got a single block, but I have not announced it at this moment. I'm just waiting. And I find that eventually another honest miner has proposed 1 block on top of it. And what I do, I immediately will announce it. So in this case, you see, there are 2 branches. This is 1 branch having 4 blocks. This is another branch having 4 blocks. In this case, if it is observed that the next block coming on top of it, it will be ignored. Or if the next block coming on top of it, then it will be ignored. So now this is a win-win situation. Either the honest miner can be successful, or maybe the attacker can be successful. It is a win-win situation. So the race is on. But this kind of attack, block withholding attack, is possible even though I don't have more than 50% of computation power. Okay, so even though I don't have more than 51% or 50%, more than 50% of hash power, still I can be successful even though I have little bit, more than 25% of computation power. How is it possible? The attack saying that if I can, I can be successful in getting some valid block earlier than other miners, then I will hide it and later I will announce it. So it is possible if in the network I am in a good position, maybe in the central position where all the transactions coming early. And if someone is at the corner of the network and they are receiving the transactions very late, so they will get the valid block late. I will get the valid block early. So if I get the valid block early, I will hide it. I will announce it later. So if in the network my position is very nice, then this kind of attack I can do even though I have little more than 25% of hash computation power. Okay, so now coming to forking. So forking, having this fork, this is also a, it creates some difficulty in blockchain protocol. So, and forks can happen because of different reason. So as I already told, forking attack can be done by the miners having more than 50% of hash computation power, but forking can also be also can also take place due to some other reason. So I'm giving 2 examples here. Suppose you say there are 4 nodes in the blockchain, and they are maintaining their blocks. This is the current existing blockchain. Suppose in the protocol some changes is going to be made. What kind of changes? The changes is that now existing protocol saying that the size of the blockchain Okay, sorry. Somehow it's quite critical time now because of some other reason, official matter. So that's why multiple calls coming, and so I have to interrupt it in between. Uh, okay, so suppose what's happening. I have some different nodes, 4 nodes, and we are maintaining some existing blockchains. And suddenly, I find that there is a change in the protocol. What the new change? Change is that initially, uh, 1 million bytes is current size of the block that the protocol allows. So maximum 1 million bytes can be allowed in a single block. This is the for the existing blockchain protocol. Suppose it is decided, let's increase the block size from 1 million bytes to 2 million bytes. So individual blocks can be of 2 million bytes also, maximum. So if this is the new protocol, this is a new protocol, it would be, these nodes upgraded to the new protocol. So maybe they are using some upgraded softwares, Bitcoin softwares, whereas some nodes might using the old softwares where the policy, the protocol saying that only 1 million bytes will be allowed. So if this is the situation that some of the nodes using upgraded softwares and some nodes using old version of the softwares, and so what will happen? Suppose the new node, the updated software, this node acting as the miner and introduced a new block. And suppose the size of this block is maybe 2 million bytes. And when this block will be broadcasted, of course, this new block, this node will accept it, because as per current policy, upgraded policy, it is allowed. But these old nodes, they will not accept it, because as per their policy, existing policy, 1 million bytes only allowed. So they will not consider it. Now suppose some old node is acting as a miner and proposed a new block. So in this case, since 1 million bytes is the size of this block, it will be accepted by this new as well as the old, everyone. So this creates some kind of forking. And this is called hard fork because it becomes permanent in the network. Now I am talking about another kind of forking, soft fork. Suppose here you can find that in this case of soft fork, you can find that suppose the change is like that, current protocol saying that only 1 million bytes will be allowed, but there is a change that let's not allow 1 million bytes, let's allow maximum 500,000 bytes. So if this is the change and they are using the upgraded software, so in this case, if this node acting as miner and creates this new block, since this block size is of 500,000 bytes, it will be accepted by everyone, including old nodes. But if any old nodes is creating some blocks, mining some blocks, even though the size is 1 million bytes, it will be accepted by the old node, but will not be accepted by the new node, because new node cannot accept any block of size more than 500,000 bytes. Again, if new node is proposing something, you can find that this will be accepted by everyone. So here is the forking. But in this case, we call this fork soft fork because since old nodes somehow having this kind of forking, and old nodes, when they are proposing any block that is not going to be accepted by most of the nodes, it means that old nodes will realize that something problem is there in the software, because whatever I am proposing, most of the nodes, they are not accepting, because most of the nodes, we assume that they have upgraded their software. So in this case, old node will think that, okay, let's reinstall, let's upgrade the software. So eventually, when they realize that their blocks are not accepted by the network, so they will upgrade their software, and when they will upgrade their software, automatically this blockchain will be replaced by this blockchain, so everyone will have same blockchain. So that's why soft fork is for temporary, it's temporary, and just after some time it will be replaced by updated version of the blockchain. But hard fork remains permanent. So therefore you can see that when Ethereum moves from Ethereum 1.0 to 2.0, that time a fork is being created, and that fork is permanent hard fork. So you already know that in case of Bitcoin, there are different kinds of attacks possible that I have already mentioned few of them. But at the same time, you see that in Bitcoin, anonymity is very crucial, because I cannot reveal my own identity, because I am otherwise people will get to know how many Bitcoins I own. So it's publicly available. So that's why rather than my real identity, what I use hash of my public key, which is some kind of pseudo random, and that makes it difficult to infer who I am holding this address. So, but because of this kind of anonymity, real identity is not revealed. That's why this Bitcoin can be used by many, bad person, and they can do different kinds of fraud, phishing scam, they can run Ponzi schemes, money laundering. Many things can be done because the real identity is not available. But there are different kinds of solutions that is happening. For example, here my research team, they are also exploring given a set of transactions and the behavior of different nodes, how they are making the transactions of Bitcoin, how they are receiving Bitcoins from different users. So there are different kinds of activities happening. So observing these activities, can I apply some kind of machine learning technique to identify, okay, these nodes can be categorized as phishing nodes, and these nodes can be categorized as non-phishing nodes. So that kind of, you can apply machine learning approaches to all the transactions that's happening in real time, and that you can accumulate from the network, and you can apply machine learning approach to classify them, to identify whether any kind of this kind of security threats or privacy threats are there or not. So a lot of solutions you can find, machine learning based solution, that are adopted in this context. So finally, you see that if I have this blockchain, I mean Bitcoin, so if it is very very secure, I mean threat is very low, there is no such attacks, so immediately the value always will be increased, right? And if the value of the Bitcoin increases, you can find a lot of people joining the network and doing the transactions, doing the activities in the blockchain network, Bitcoin network. So automatically the ecosystem will increase. If the ecosystem increases, then those kind of attacks such as 51% attack or maybe block withholding attack, those kind of attacks will be minimized, because if a lot of people are there in the network, ecosystem is very large, we can expect that lot of more number of honest miners will be there, and therefore the Bitcoin blockchain will be somehow safe and secure. And in this case, if ecosystem increases, security also will increase, and if security increases, then value of the cryptocurrency also will increase, and it will attract more people over the time. So it's circular in nature. So but there are, so if you want to know get to know about different kinds of security and privacy concerns of Bitcoin, you can check this paper. It's really good paper. Okay, so now maybe now I can start with other perspective, looking at Ethereum. Okay. So here, Ethereum. I'm sure that you have gone through that Ethereum. This is also a blockchain platform as like Bitcoin, but there is a difference. And if you look at the market price of Ethereum as a Ether is the corresponding cryptocurrency corresponding to Ethereum platform. If you look at Bitcoin and Ether marketplace, you can see there is a lot of change, lot of difference. If Bitcoin is around, I don't know the current, I have to search in the Google. If you find that, okay, current Bitcoin price is 21,000 USD, maybe Ether price will be maybe 2,000 around USD. So huge difference. So Mike, suddenly, this kind of question will come in mind, that if Bitcoin is very, very high market price, if the market price of Bitcoin is very high, popularity is very high, and if the market price of Ether is very low, why should we go for Ethereum? Why Ethereum is useful? Why not only focus on Bitcoin? That kind of questions will come out. In this case, to answer this question, what we can say that Bitcoin versus Ethereum, if we consider Bitcoin, the Bitcoin can be compared as like, the old calculator, where only some kind of arithmetic, some kind of plus minus multiplication can be done, nothing else. And as I told that anyone, when I issue a transactions in the blockchain Bitcoin, any one of the member in the network can check the validity, and that validity can be checked by extracting some information from the transaction that I have already mentioned, and to perform some kind of stack based execution. And those information is being written through some language which is called Bitcoin scripting language. But this Bitcoin scripting language is designed or introduced just to allow any user to check the validity only, that whether this corresponding transaction is valid or not valid, nothing else. It does not support any kind of loop, any kind of for loop, any kind of while loop, any kind of recursive calls, it doesn't support. You know, in case of C program, Java program, they support all those things, but Bitcoin scripting language does not support. That's why I can think Bitcoin as like old calculator, whereas if I look at Ethereum, I can say they are like, you know, smartphone today. In smartphone, you can find calculator as like old, right? They have the application calculator. So here you can find not only calculator, but they also will have lot of different applications in smartphone. So similarly, I can say that Bitcoin is just, you know, just for cryptocurrency transactions, nothing else. Whereas Ethereum is more than that. Ethereum can do all these cryptocurrency transactions, that's fine. The corresponding cryptocurrency is Ether, but at the same time, Ethereum will support application development, whatever applications, I mean, decentralized application development that you already know. So that's why Ethereum is nothing but, you know, world's programmable blockchain, and Ethereum supports different programming languages. Solidity is most popular programming language. I'm not going in detail of all these things. So this is the view that you have if you write some Solidity smart contract in Solidity language high level. This is similar kind of, you know, JavaScript or some object oriented thing, where rather than class you are just mentioning contract, and other things almost same, having minor difference considering this underlying execution environment for Ethereum. But here, after that compilation, you will get some kind of bytecode, and those bytecode will be deployed in the blockchain, right? So in a decentralized manner, everyone will have the blockchain copy, and when we deploy some kind of smart contract, that smart contract will be inside the blockchain. So everyone will have the smart contract code, and if I want to execute some function in the smart contract, I can issue a transaction. That transaction will be considered by the miner, and accordingly the code will be executed whatever miners will suggest. So everyone in the network will execute the code in the same manner what the miner will suggest when the block will be created, considering all those transactions, right? I hope that you already know. If you don't know, if you want to know a little more about that, please feel free to ask me. You can tell me that you need some information, then I can convey it to you. But I'm assuming that you already know about all these things. And you know that how all these centralized untrusted parties can be ignored and can be replaced by blockchain smart contracts. So for example, Amazon can be replaced by this blockchain smart contract, and user seller, they easily can participate in this e-marketplace, right? So rather than Amazon, we can have this smart contract where we don't have to pay, I mean, seller doesn't have to pay any kind of service charge to this Amazon. Similarly, Ola, Uber also we can replace, and we can create this kind of smart contracts and blockchain network where the rider and the driver, they can interact with each other and can do whatever Ola, Uber currently doing. Similarly, supply chain, you can find that if I want to buy something, the consumer is buying something from the market, and he wants to check or she wants to check whether the product she is purchasing is genuine or not, it is manufactured by the original company or not. So everything can be checked if the complete supply chain information will be stored in the blockchain, and that will be extracted by the consumer to check, because immutability nature and accountability and auditability, everything will help the consumer to make the whole thing transparent and to trust the thing. What I want to start here, because what my session talks about, that security perspective or safety perspective of decentralized applications. So I want to jump to that different security concerns or vulnerability concerns in decentralized application corresponding to smart contracts. So maybe I can skip all these things, but I want to know how many of you, I mean, do all of you know about Solidity? Do you know Solidity programming language, smart contract programming language? Then I have to mention some of the language construct, and then I have to say that okay, these kind of things may create some kind of vulnerability. Okay, I am assuming that you already know Solidity since I am not getting any response. So assuming that you already know, so let's start with those vulnerabilities. So you know that the bugs, of course, if you develop any software, bugs always will be there. You cannot guarantee that 100% bug free. But what I mean, and there are certain softwares which are very very critical. For example, if you are traveling and you are going for a very important meeting and suddenly you find that this software is not working, so this is difficult for not only for passengers but also the management flight management company. So I mean, this kind of software is very critical. Suppose you are going to issue some boarding pass and suddenly this software is not working. It's very difficult. It's a critical situation, right? So there, and I can show you one such example of where you can find that. If I have this, yeah, I have probably. So you can find that there is maiden flight. So launch of some Ariane 5 flight, and it has been launched successfully, but after 40 seconds, just after 40 seconds, it got destroyed.
साठी आपल्याला अप्लाय करावं लागतं का सर्टिफिकेट फाईन ते मागे सर्वेला आलो होतो ना तर सर म्हटले की सर त्याला अप्लाय करायला पाहिजे.
Yes, just after 40 seconds it got destroyed. And do you know what is the reason of this? The reason is just very very simple thing, just the conversion of integer float value into the integer value. So if you convert float value in the integer value, there will be some kind of information loss, and that information loss caused this huge loss. So what I want to convey, that many softwares are there which are very very critical, and that's why testing is very required in this case. So sometimes Bill Gates also highlighted that we have as many testers as we have developers, and rather than saying this is the development software development industry, rather we can say that this is testing industry, because there must be lot of testers all day. So when we go for critical systems, there can be business criticals, for example, banking systems, all those things, mission systems, mission critical systems, for example, the satellite launching, all these things, safety critical systems, for example, this kind of this traffic controller or flight management systems, all this. So when I look at these blockchain-based decentralized applications, and they are dealing with that cryptocurrency transactions, all these things, of course, if those kind of those kind of decentralized applications developed by smart contract, they are in this kind of critical scenarios, we can call them also critical system, right? So when they are dealing with some kind of some kind of cryptocurrencies, of course they are financial critical. So therefore this is very important to ensure that these smart contracts, whatever we are developing, they are completely safe, they are completely secure. So before deployment, we have to ensure that, because after we deploy, we cannot change it because of immutability nature of the blockchain. So that's why before deployment, we have to ensure that they are perfect. So in that case, of course, we cannot guarantee 100% perfectness in all aspects. So we have to have some kind of specific property that we are interested in, and we have to prove that these smart contracts are correct with respect to that specific properties of interest. So for that, formal methods are there in place, and formal methods are very relevant to apply in case of smart contract as well, to ensure that smart contracts are correct with respect to given properties, and we have to ensure that before deployment. And if we find that this is fine, certify it, deploy it. Now, I am just trying to mention one just very crucial kind of attack that has happened in the history of Ethereum, and here 32 million USD has been stolen. It's a very big attack in the history of Ethereum. But if you look at how this attack happens, this is really interesting. So I want to say something about this attack, how re-entrancy attack, if you develop some decentralized application using Solidity, this attack can happen, and you have to be careful about that. So let me tell you that how this attack happens. Just high level view. Suppose this is one smart contract where everyone will have some deposit value here. You can deposit something, I can deposit something. So when I want to deposit, I have to call the credit, I have to give my address, and in this case the corresponding deposit mapping variable, the amount that I want to deposit will be stored. So I am depositing to this mapping variable over the time. Not only me, you can also deposit, many people can deposit in this smart contract. Now when you all are depositing, it may also happen that sometime I want to withdraw some of the amount. So when I want to withdraw, I will call this withdraw. I will send some amount. In this case, what would be checked that whether I have enough amount or not, what I am requesting for. If I have the amount that I am requesting for, then the money will be transferred through this one. And after that, from the deposit, those amount of money will be deducted because this is already transferred. After transferring, that amount will be deducted. So here, you can find that if this is happening, now I am looking at this smart contract where it is observed that some withdraw function is being called. When this withdraw function is being called, it will call this function and then will pass some kind of amount, and then it will be checked that amount is available, yes, then money will be sent. When the money will be sent, it will be called, it will call the same fallback function always to transfer the money. Suppose it is asking for 100 Bitcoin. Suppose in the deposit you have 100 Bitcoin, sorry, Ethereum, 100 Ether. And now you are calling to withdraw all the 100 Ether. In this case, the 100 Ether will be transferred to you. Now what will happen? If you enter this function, again another withdraw will be called with another 100. So again, you see the deduction has not happened. So since the deduction has not happened, and again you have come to the beginning of this withdraw function, again another 100 will be sent. And it will continue. So multiple 100 Ether will be transferred. Because this statement, the last statement where you are decreasing the balance, it's not actually executed. Always the money is being transferred and always the call is being happening. I mean, it's some kind of repeated call and repeated money transfer. This is the very simple code. Suppose as a programmer, you have written this code, but small bug can create a lot of huge financial loss. So that's why this is a kind of critical settings, and you need to check that whether such kind of vulnerability exists or not. So this is the visually shown. I can skip these things here. Another example I can show you. Look at this code. If I find this is unsigned integer, this is unsigned integer, where the minimum value of the unsigned integer is being stored, the maximum value of the unsigned integer is being stored. Now I am decreasing the minimum value by 1. I am increasing the maximum value by 1. Since it is unsigned, if I decrease 1 from 0, it should be -1. But since this is unsigned, it will become again the highest value. So looking at this code, you might feel that finally I will get -1. But actually when it will be executed, you can find no, it's not happening, that it's not becoming -1. it's becoming again 2 to the power 256 minus 1. So it's getting the highest one. So what you are expecting and what's happening, there is a difference. So that's why you have to be careful. So this is called integer overflow or underflow. Timestamp dependency. This is really interesting case where you can find a lot of things happen. I mean, miners can also act as attacker in case of decentralized application when this kind of smart contracts will be involved. So in this case, you find that I define one salt value using current block timestamp. I mean, the recent block that is there in the blockchain. Using the timestamp in the block, always you will have timestamp, and with the timestamp you assign the timestamp into some variable. And what you are doing using that variable value, you are creating x. Using that salt, you are creating some y. Using that y, you are creating seed. And then using that seed, you are creating some h. And then using h and x, you are generating some value. So you can find that there is a dependency, right? Y is being used here, seed is being used here, h would used here, x will be used here, seed also will be used here. All these things are going to be used here, right? Not but h is used.
सबमिशनचा एक प्रिंट
Value. So if sort
आपण नाही का ते
value
साइन घेतो
will change, all things will be changed, and finally this value also will be changed because of the dependency. So everything is changed sort value. Now you see that I have created one very system. I call a random function. Is function. I create random value. This value is nothing.
मी नेटवर्क केलं आपलं गेलं का मग नेट माझं कनेक्शन गेलं
मोबाईल वरती चालू आहे म्हणजे
कनेक्टेड म्हणतोय पण तो तर कनेक्टेड दिसायला दिसतंय ना पण केलाय आता माझा मोबाईल नाही याला मोबाईलचं लावलं मी बंद करायचं होतं. बंद केलं की काही नाही झालं सुरू नाही RGI सुरू झालं का RBI सुरू झालं.
And these transactions later, so it means that buyer will buy it using 100 ethers, and then according to these transactions, price of this product will be increased. That's perfect. There is no issue. But if this happens, that this transaction is being considered second and this transaction is being considered first, I mean, the order can be decided by the miner, no? You cannot force to consider this transaction in some order to the miner. You cannot. So miner considers this transaction first. So what will happen if miner considers this transaction first, then this price will be increased, mobile phone price will be increased, and then if this transaction will be executed, then 150 ether will be deducted from buyers. So you see, buyer has found that 100 ether is the price, and when the actual deduction happens, buyer finds that okay, 150 ethers have been deducted. So this is a loss to the buyer. So the owner can intentionally create this kind of issue, increasing the price again and again when other buyers are trying to purchase it. So this is called transaction dependency thing. There are certain issues, like for example, if you have this kind of for loop, you can find that there is a array length, and this array length user can set. So if I can set this array length very large, so this execution will happen lot of time, many iterations will happen in this case. And every execution in Ethereum requires some kind of cost. It is called gas cost. So in this case, lot of gas cost will be consumed, and
बरोबर आहे, आज ही पण
user
आली
has to
लाईन.
pay lot of price for it.
म्हणून आपण दिसतोय आज.
So that's why it's not a good idea to
नाही, नाही,
use
गायत्री,
some kind of
गायत्री.
costly computation, and dependency on external environment not expected. Maybe okay, so there are so many different kinds of vulnerabilities exist, and you can find lot of different vulnerabilities in smart contract, reentrancy attack, transaction ordering, block timestamp dependencies that I told, integer overflow, underflow. There are so many different vulnerabilities, and now there are so many different analysis also done. But some can be done compile time, some can be done during runtime, and their formal methods are very crucial in all those cases. And there are so many different tools also exist in the market to check that whether your smart contract is safe or not safe, vulnerable or not vulnerable, and that is required to verify. Maybe I can skip all these things. So there are different verification approaches that I can skip because of interest of time. Finally, there are so many different tools available. You can check, you can use all those tools. This is a very popular tool to check that whatever decentralized application you have developed, they are correct or not, or there is any vulnerabilities or not, and accordingly you can deploy it. I can skip all these things. And interesting thing is that now currently what is happening, that I told about formal methods, right? Verification of or analysis of this smart contract to check that whether they are correct or not. But those formal methods are mathematics based, and there is a lot of issues like scalability or adaptability of by industry because of the costly solution. But of course, they are mathematically supported, and that's why whatever they will decide that this smart contract is vulnerable or not vulnerable, that is sound. The analysis is sound or correct. But because of this costly solution, today people are also exploring can machine learning be applied in this case to minimize the cost. Yes, of course, the solution, I mean the correctness analysis or verification, that could be very precise or highly precise in case of formal methods. But when we move towards machine learning can be the less costlier solution, very cheaper solution. But problem is that precision, there can be a lot of false positive, false negative in case of machine learning. So if you apply machine learning to check whether it is vulnerable, and it is saying no, it's not vulnerable, and finally you get no, when you are in use, you find that okay, there is an attack. So this is very dangerous, right? So false negative can lead to very difficult situation, or even false positive, still it's okay. Now in those cases, if this is the situation, so that's why people are using various machine learning based solution also to achieve this
झालाच
vulnerability
असणार
checking.
एकदा जाऊन
Okay, so maybe I can skip. So these are different machine learning based approach to identify whether the smart contracts are vulnerable or not vulnerable. Okay, so I am skipping these things. If you have interest, you can look at it, and thank you. So with this, I can conclude my session. Uh, if you have any question, please feel free to ask me.
हो का हॅलो हा सर कसली कशाची मीटिंग काय प्रॉब्लेम आहे तुझ्या अटेंडन्स अटेंडन्स नाही
Okay, so thank you. I think there is no such question. Feel free to interact with me if you have any question.
Sir, I have one question.
तिकडचं जे
Yes.
अटेंडन्स आहे मग ते अटेंडन्स नसतील करत ना
You were talking about forking attack. You said it is not observed. So is it not in working or is not used only now?
मग दुपारून हे सेशन मग 2-1
Forking
वाजता
attack can happen anytime.
2 वाजता
This is
हे करून
possible.
टाका link.
Now what is happening to make this forking attack successful? User
ती
or
मागचीच link
miners
ठेवू ना मग.
have to
ते
have
link करायला
more
काय
than
करायला लागेल?
50% of computation power.
मी पाहिलंच नाही
And
त्यांचं
if
काय
you look
मेसेज
at
येतो
globally, lot of people have invested lot of hardware
कशाचा?
devices and their computation power is very, very high. So when I am going for
हो ना.
attacking these things,
तसं
forking
नाही,
attack,
तो problem
I need
नसतो sir.
this,
त्यांचा problem
my
तो नाहीये.
computation power
Actually
should
कसा
be more
problem
than
झाला, sir?
50%
हे
of
जे
that
second yearचे
global
मुलं आहेत,
computation power,
मला जेवढं माहिती
which
होतं ना,
for me
हे मुलं
it's
टीला म्हणजे
impossible.
आता जे फायनल इयरला
So that's why,
त्यांच्या मी पूर्ण
since I
contact
don't
मध्ये
have much
होती. आता हे
computation
जे
power as an
third yearला
individual,
आहे का, हे थर्ड इयरला आहेत ना हे मुलं आता.
therefore I
तर या
cannot
मुलांचं
perform
जे
that
जे आधी कंबाईन
forking
सरांकडे
attack.
होतं आणि
But
त्याच्यानंतर
if
मग ते
you have more than 50% of
त्याच्याकडून
computation power, you can be
मंडेला
successful.
टाकलं त्यांनी. ठीक आहे
Till
मी
now.
हे करून टाकते.
Even today also you can be successful
Mondayचा
if you have
message येतो,
computation
sir.
power very high and it's more than 50% of global computation power.
Okay, and does 51% of attacker, how does it relate? If it relates, then how does it relate to double spending?
Yes.
तोच तर problem
If
झाला.
I have more than 51% attack, I mean more than
Attendance and
50% of
paper.
computation power, for example, what I can do, this is my blockchain, and I observe that in the blockchain there is one transactions where I have sent money to you because
पण
I
मग
have
तिने,
purchased something from
personally
you.
बोलायला पाहिजे
That's
ना,
why
हे
I have
आपण हे
paid
issue
some
sir आपण
Bitcoin
meeting
to
मध्ये
you.
नाही घेऊ शकत.
That transaction is already there in the Bitcoin. I mean in Bitcoin blockchain.
तसं नाही तिने इथे
If I
बडबड
want
करायला
to
नको ती. असं
send
म्हणते,
the
ती
same
चांगली
money
forward.
to my friend, what I do, I will create a new transaction.
ठीक आहे.
I will send the same money to my friend. I will mention that transaction that way. In the input section, I will refer to the same money and I will send it to my friend. That new transaction I can create. What I do, because I have lot of computation power, I will create a new block. I will consider this new transaction in the block and I will do lot of, I'll do the mining process. If I do mining process, not only a single block containing this new transaction, I will get, for example, thousands of blocks at the same time because I have lot of computation power.
Question सुरू आहे का?
So what I do, I will create a new fork considering all these 1,000 blocks that I have mined just now. And if I add all those new blocks containing that double spent transaction inside in a new fork, and since the length of my new fork
आणि मी
is
इकडे
higher
विचारायला पाहिजे ना काय problem?
compared to the previous blockchain copy, so the longest chain will be now
मंगळवारचा message
considered
आहे
as the valid blockchain and the shorter one will be
नागपूरच्या
ignored.
मुलांचं.
So
We are
the
facing some
existing
issues here in GHR
Bitcoin
Singapore and we
transaction
want to tell
through
you
which I
something
have
about
sent money
attendance
to you,
and
that will be
paper,
ignored by
PS.
the network, and new transaction containing
Kindly
this new
request you to
fork
take
will be
over meeting
considered.
as soon as possible.
Am I able to convey?
Yes, sir. Got it.
Okay, thank you. So I can create a new fork because I have a lot of computation power, and there I can introduce the new, double spending kind of transactions which people will accept, and existing transactions will be ignored.
Okay,
Yeah.
sir. Understood.
Any other questions?
No, sir. Thank you.
Okay. Thank you.
May I conclude?
Yeah, of course. Thank you.
A heartfelt thank you to you, sir, for sharing your valuable insights today. The participants and us truly got inspired a lot from the dedication, your achievements, and presentation served as a true inspiration. Thank you, participants, for your engagement. In closing, let's carry forward the spirit of learning and innovation inspired by today's session. Thank you, sir, and all the attendees for joining the mesmerizing session. Thank you.